The last thing we need to talk about is zero exponents. Any number raised to the zero power equals 1. Any number, exponent, value, anything raised to the zero power equals 1. So let's look at some examples. Our first example is x to the zero power. The only thing in this expression is x. It is being raised to a power of 0, so that means the answer is 1. X to the 0 power equals 1. Number 2, there are now 2 parts to this expression. There is a 5 and there is a y to the 0 power. 5y to the 0 power is the same as saying 5 times y to the 0 power. Five is not being raised to a power. The power is invisible, and we know that ones are invisible, so really this is 5 to the first power. So 5 does not change. 5 stays the same. What does change is y to the 0 power, because anything raised to the 0 power equals 1. So we bring that 5 right over, times, and let's simplify y to the 0 power. That equals 1. 5 times 1 is 5. So your final answer to this example is 5. Now let's practice those zero exponent rules. You are going to do number 5 and number 14. The first one, number 5, is ab to the 0 power. Remember, that's a times b to the 0 power. The only thing being raised to the 0 power is b to the 0 power. So you are multiplying a times b to the 0 power. All right, and number 14. This one is already separated for you. This one is 22 to the 0 power times 22 to the 4th power. Now let's apply our zero exponent rules with our other properties. Starting with example 3, we have 10y to the 5th over x to the 0 power. Where is the 0 power? The 0 power is in the denominator. This is x to the 0 power. So we need to simplify this fraction. We need to change x to the 0 to 1. So we have 10y to the 5th power over 1, which we know when you put a number over 1, that number is a whole number, so your final answer is 10y to the 5th power. y to the 5th over x to the 0 equals 10y to the 5th power. Number 4, now we're bringing in some quotient rules. We're going to have to use the quotient of powers property. So there are a lot of factors in this problem, so let's rewrite it so we can see it a little bit more clearly. 3 times x to the 5th times z to the 0 power, and that's over x squared times z squared. Notice how I line up my matching variables. I put the x's right on top of each other and the z's right on top of each other. And then we also have a coefficient over here, this 3. So let's work our way from left to right. The first thing I have is a 3. The 3 does not have anything in the denominator, so we know that's going to be a 1. So you can bring that 3 right on over. If you want to put the 1, you can, but we don't need that 1. So right now, our fraction is 3 over 1. Now, we have x to the 5th power over x to the 2nd power. X to the 5th over x to the 2nd. This follows our quotient of powers property. Our quotient of powers property tells us to subtract. So that would be x to the 5 minus 2. X to the 5 minus 2. Then we also have z to the 0. Z to the 0, anything to the 0 power equals 1. So I'm going to replace that with a 1. I'm done with my 3. I'm done with my x's. I dealt with my z to the 0. The only thing I have left is z to the 2nd power, and that's in the denominator. So I'm going to put z to the 2nd power in the denominator. Now my 1 and my z, they don't do anything. They can't combine. I can't simplify them. That 1 is a 1. So now I've dealt with all parts of this problem. So now it's time to simplify. 3 over 1. That's 3. X to the 5 minus 2. That's x to the 3rd times 1. Well, I don't need that times 1. Over 1 times z squared. That just equals z squared. So 3 x to the 5th z to the 0 over x squared z squared equals 3 x to the 3rd over z squared when you simplify. All right, number 27 has a 0 in it. So this is the problem that you are going to do. Remember, separate all of your factors. You have c to the 10th times d to the 0 over c to the 9th times d to the 5th power. Solve this one, or simplify this one.